Let's look at the graph of logarithmic functions and where they came from. So remember, log functions are the inverse of exponential functions. So if we look at an exponential function, for example, f of x equals 3 to the x, and we calculate algebraically the inverse, we would first change f of x to y, so y equals 3 to the x. Then we would swap x and y, so x equals 3 to the y, and now we would need to get y by itself. And if I convert that exponential to log form, I would get log base 3 of x equals y. So the inverse of f of x equals log base 3 of x. In general, if f of x equals a to the x, then f inverse of x equals log base a of x. If we look at a graph, the graph of the exponential is in green, the graph of the log function is in red, and they are reflections of each other over the line y equals x. In general, characteristics of log functions are, it has a domain of x is greater than 0, the positive reals, or in other words, in interval notation from 0 to infinity. The range of a log function is all real numbers, or from negative infinity to positive infinity. A log function has no y-intercept. It does have a vertical asymptote at the y-axis, which is the line x equals 0, and it has an x-intercept at 1, or the point 1, 0. And the graph is continually increasing.